This is a report on a research project conducted at the RAND Corporation under Air Force sponsorship. The aim has been to furnish the individual scientist with a modest computational capability on a demand basis. We call the system JOSS, standing for Joniac Open Shop System. It is an online, time-shared use of the computer. Joniac is a venerable machine, but small in today's standards. Coupled to it is a special purpose buffer for messages to and from remote consoles. Each console consists of an electric typewriter and a few buttons and lights. At present, 8 such stations in various locations in the RAND building are connected by telephone lines to the buffer. An executive routine in Joniac serves up to 8 users at a time by interpreting and carrying out commands given in a simple language. Let's watch Fred Gruenberger and Charlie Baker demonstrate some of the features of JOSS.
JOSS may be used in 3 ways: as a printing desk calculator, as a stored program computer, and, most productively, as a combination of these 2. First, we will demonstrate some of JOSS's arithmetic capabilities. Multiplication must be indicated by a centered dot. We divide by using a slash. And an attempt to divide by 0 will result in an error message. An exponent is indicated by an asterisk. Several expressions may be evaluated on one line, and a blank line is indicated by an underscore. The arithmetic expression shown in this chart may be evaluated by the addition of parentheses and brackets. A number of functions are available. The argument is enclosed in parentheses. Trigonometric functions are provided, and we notice that numbers may be up to 9 decimal digits. Logarithms are to the base e. JOSS is correct. The variable y is undefined, but a set statement will serve to define it. JOSS functions are available to take the integer part of a number, the fraction part, the digit part, and the exponent part. To use JOSS as a stored program computer, we may ask JOSS to store a statement rather than execute it immediately. This is indicated by prefixing the statement with an identifying number. We will now ask JOSS to execute this step a number of times, varying x from 1 in steps of 1 to 100. Our table would look much better with each set of values on one line. Let's interrupt JOSS by pressing the interrupt button. JOSS has calculated several lines and will stop when they have been printed. We will change our program step by replacing it with one that calls for typing in a form. We must define this form. JOSS does not require us to be perfect typists. A line may be killed by ending it with an asterisk, and JOSS will ignore this line. We've corrected our mistake. We may now use in the form underscores to indicate the position of fixed point numbers and a string of dots to indicate that scientific notation is desired. Go will tell JOSS to resume calculation at the point of interruption. Our output looks much better now. Let's dress it up with a heading. Again, we will interrupt. JOSS will insert step 1.05 before our type statement and will request part 2 as a subroutine every 40 lines. Part 2, that is, all steps numbered 2 point something, asks for a new page and a heading line. We must define this heading. This time we'll ask JOSS to start all over from the beginning. This looks much better, but an occasional space between lines would dress up our output nicely. So we will interrupt again. Step 1.07 should give us an extra space every 5 lines. Let's restart. Now that our program seems to be checked out, we may ask JOSS for a copy of the program, the forms, and the value of all variables. We can now communicate with JOSS well enough to attempt a problem. An example is found in McCracken's Guide to Fortran Programming. First, we'll need the constant 2 pi. Next, we can store a program to compute the required factors and an approximate time interval. And we'll type out these values. Next, we need to enter the parameters for our specific problem. Now we can ask JOSS to compute these factors. These look fine with the exception of that rather messy-looking time interval. We can change it to a clean one. And knowing that our interval is small, our program can print the time in milliseconds rather than seconds. The program to compute and type consists of a single step which will print in a single form. The form may include any additional information we wish to print out with our answers. We can now ask JOSS to execute our step for 100 time intervals from t equals 0 in steps of d to 100 times d. Since our program seems to be gold star, let's record it. The program is finished, so we might as well erase it, its forms, and all associated values from JOSS's storage. That was admittedly a textbook problem. In preparing reports on its work for the Air Force, RAND authors frequently have the problem of evaluating an expression for a number of values to aid in the preparation of a graph. Here is one such expression. Let's do it on JOSS. We'll start on a page with a heading. Step 1.3 will evaluate our formula for 4 values of P: 81, 72, 45, and 9. And for L equal to 0.1, here we can backspace and strike over and go on. For L equal to 0.1, 0.2 in steps of 0.2, up to 2. Part 3 evaluates our expression and types out the answers. Next, we need to enter the constants required to convert degrees to radians and to convert logs from base E to base 10. Then we can ask JOSS for the results. Again, we'll keep a record of our program before we delete it. JOSS can operate with indexed variables, and a stored program may call for values of variables to be entered during execution. We'll vary the value of the first index, x, from 1 in steps of 1 to y. And vary the index y from 1 in steps of 1 to 8. We enter the value of each variable as it is requested by JOSS. When all of these values have been entered, we may proceed to have JOSS calculate with indexed variables, as would be required for problems more complex than we have been able to demonstrate here.
You have just seen a demonstration of many features of the JOSS system. As was pointed out, this is an experimental system designed to provide individual scientists and engineers with a personal, on-demand computing service. As a side aspect of the experiment, we hope to gain insight into the interface problem between a man and a computer. The system shown here is currently available to RAND's professional staff. Our experience in using JOSS, our observations of user behavior, will be the basis on which to continue research. Later model systems will certainly differ from what you have seen. JOSS is one of many current efforts in online, time-shared use of computers. The goal of the JOSS project has been to demonstrate that the ability to be online with a computer, given a reasonable language and almost continuous interaction, leads to a powerful computational tool. It is probably too early to forecast the ultimate effect of such systems, but for a certain class of problems at least, the programmer as the middleman between the problem and the machine is no longer needed. JOSS represents, we believe, a significant step forward because of its intimate interaction between man and machine.